This slide is on recursive function. Okay, so I think all of you know about recursive function. Recursive function means a function is calling itself. This is known as recursive function. You have learned it from Java class. So function 1 is the function name. I am calling that function within this function. So calling a function again and again, and if it is same function, then it is known as recursive function. So what is recursive function? A function that calls itself. Okay. How to implement recursive function? By using stack. So recursion occurs when a function is called by itself repeatedly. Now, one thing you don't know, we haven't discussed about stack, right? So stack will come in data structure. In the next module, we have stack. Then we will show you how basically recursive function implemented. Okay. Now we are just skipping this part. We are skipping this part and we will go with the other part. Okay. So recursion is an elegant programming technique. Is it a best way to solve a program? So you have two ways. One, iterative, and second one is recursive. Two type of way for solving any program. Which one we should use, recursive or iterative? Always remember, iterative is good one, then recursive. Okay, so always try to choose iterative. Now in some specific problem, always remember, in some specific problem, recursion is the best way. Then iterative will not work like that. So in some specific problem, you have to use recursion, no other option. Okay. So what are those problems? So the basic problem we can tell you, factorial. You know about factorial? All of you know about factorial, I think. So in factorial, recursive or recursion is the best way, not iterative. But in most of the cases, iterative will give you good solution. Okay. So first of all, recursion is an elegant programming technique, not the best way to solve a problem. Why? First of all, it will do it by stack. So stack is not a good way of programming. Okay. So there are different type of programming or data structure we will tell you. So stack is one of that. So stack is not the best way. It is one of the way, but it is not the best way. It utilizes memory inefficiently rather than iterative. Okay, so iterative will use the memory efficiently, but recursive will not. Slow down execution speed, and functions call require different type of jumps and saving the current state of program onto stack before jump. So these are the problems of recursive. So why we will use recursive? You will ask, then why you have dedicated one class for recursive? Because it is too handy to solve several problems. So for specific problems, we have to use recursive. First thing. Second thing, it is easier to implement and easier to understand. Two things, easier to implement, easier to understand. So in your lab, in one lab, we will give you recursive problems. Okay, just do our labs. One lab is fully dedicated on recursive problems. So today we will try to learn recursive problem, and we will try to learn a specific recursive problem which is known as Tower of Hanoi. Okay, so this is a specific problem from where you can think recursion, the concept of recursion came. So we will try to learn this specific problem, Tower of Hanoi. So any question up to this? Any question? Otherwise, I will show you how to write this recursive problem. So the first problem should be very basic, that is factorial. Next we will go for Tower of Hanoi problem. So up to this, tell me, any problem? No, we can continue. Fine. So all of you know, but I am telling you again. So first of all, think I want to find factorial of 5. So integer n equal to 5. Each and every time what I am calling n into fact n minus 1. So what will happen? N, that is 5, into fact n minus 1, that is 4. If n equal to 5, then n minus 1 will become 4. So again I am calling factorial. So what will happen? N into fact n minus 1. So n means 4 into fact n minus 1, that is 3. Again I am calling this factorial. So what will happen? N into n minus 1. So 3 into fact n minus 1. Now 3 is n. Here n equal to 4. Now n equal to 3. So 3 into fact n minus 1, that is 2. Again it will go here. Again it will call. So what will happen? 2 into, now n equal to 2, right? Fact 2 minus 1, that is 1. Now again it will call fact. Now there should be one base condition, or you can say terminal condition. Terminal or base condition means where the program will end. Otherwise it will go for infinite loop, right? So we should end our program somewhere. So this line is known as base or end or terminal. Okay, so n equal to 1, if it is, then I have to return the value n. So if n equal to 1, I will return a 1. So fact 1, it is in base, right? So it will return 1. So 2 into 1, what will it become? 2. So 2 will go here. 2 into 3, what will it happen? 6. So 6 will come here. 6 into 4, what will happen? 24. So 24 will come here. 24 into 5, what will happen? 120. So 120 will go here. So fact 5 equal to 120. So have you understood? Have you understood how factorial in recursion works? So in recursion means it will call itself again and again. So fact 5 will call fact 4, fact 4 will call fact 3, fact 3 will call fact 2, fact 2 will call fact 1, fact 1 to call fact 0. But no, it will not call, because it will go to the base condition. So for the base or terminal condition, I will end, and then I will just go above and will calculate each and everything. So this is the whole recursion program concept. So this is the concept. So for n equal to 5, let's see factorial 5, then factorial 4, then factorial 3, then factorial 2, then factorial 1. This factorial 1 will return 1. So it will return 2 into 1, that means 2. 2 into 3, that means 6. 6 into 4, that is 24. 24 into 5, that is 120. So it will return you 120, this value. Fine. Now what is this recurrence relation? Recurrence relation means it will happen multiple times. So can I make a formula or a standardized formula by which I can tell what will be the time complexity or what time will be needed for completing the whole program? So what is recurrence relation? Time needed for completion. Okay, so for a program to run, how much time it will take? So this is known as recurrence relation. So next day our class be on recurrence relation. So today I am not going to that detail. So this part we are skipping and we are going, or we are trying to focus only on recursive programming, only on recursion. Fine. Now I have already told you it will happen through stack. Now what is stack? How it will happen? So I will show you this slide again after stack. We are skipping this. Our main focus is on recursion. So in factorial you have understood what is recursion. Now a special problem known as towers of Hanoi. So this is a special problem for recursion and today we will learn this, and this is our syllabus for recursion. So what is Tower of Hanoi program? Tower of Hanoi means in Vietnam there is a city known as Hanoi. So in Hanoi there are some peaks, or you can say it is towers. Okay, so there are 3 towers. Now I have n disks. So think about, this is your first disk, this is your second disk, and this is your third disk. The last one should be your biggest one. This will be your middle one, and this is very small disk. Okay, so I have different towers and I have some disks. Now what is my work? My aim is to transfer this disk in this disk in this tower. So I have to move this disk to this tower. Fine. So shifting from this tower to this tower. So you can shift. So you will shift this one first, then this one, then this one, and it will be shifted, but it will be easier. There is a trick. So you have to remember the trick. The trick is 2 conditions are given. 2 conditions are given. One, or I can say 3 conditions are given. Basically 3 conditions are given. One, only one disk at a time. So this is your first rule. So you can't take 2 disks and shift there. No. So first condition should be 1 disk at a time. Okay, fine. Second condition is it should be done in the same manner, or I can tell size should remain like this. That means The biggest one should be at the bottom, middle one in the middle, and the top one at the top. So two conditions I have told you. One, only one disk you can move. Two, the size should remain same. That means the biggest one, then the middle one, then the top one. So on a small disk, you can't put a large disk. This is not allowed. So on a large disk, you can put a small disk. So two conditions. And the third condition, you can move only the top disk. So if it look like this, you can't put this disk out of this and put here. No, you can't. What you have to do? You can shift only the top one. So these things are given. Now you have to solve this question. So again I am telling, there are different towers. In one tower there are 3 disks. What you have to do? You have to move the disk from one tower to another tower. 3 conditions are given. You can move only one disk. You can move only the top disk. And 3, size should remain same. That means you can put a small disk over a large disk, but you can't put a large disk on a small disk. Fine. So these 3 conditions we will maintain. So let's start how to do this. So for first time we will take one disk and we will try to do this. So first of all, this slide is telling you, you can do it for 3 disks, you can do it for 7 disks, you can do it for 10 disks, you can do it for 20 disks. So basically you have to do it for n number of disks. So for example, we can tell 3 disks, 5 disks, 10 disks, but you have to do it for n number of disks. What you will do? So 3 things: tower, these are the towers, these are the disks. So largest, then the middle one, then the smallest one. So you can't put it in other ways. Just remember. So let's start with one disk at a time. So in this slide, these rules are given. We have already discussed this. So I am going to the next slide, this one. Okay. So here, let's start with one disk. Now, the towers have some name just to give you an idea what it will do. So basically tower doesn't have any name, but here we will take some name to learn what the towers will do. Okay, so 3 towers are there. One is beginning tower, one is end tower, and one is auxiliary tower. So what is beginning tower? From where you will begin your step. End tower, at the end where your disk should lie. So that is end tower. And what is auxiliary tower? I will take help of the auxiliary tower if needed. Okay, so beginning tower means start tower, end tower means end tower, and auxiliary tower means helping tower. Just remember, it is for helping. Now for one disk, what you have to do? It is very easy. So what you can do? You can put this disk to this disk. So how much time you need? 1. So in one step you can do this. Now think about 3 disks. Check what I have shown you, it is here. Think about for 2 disks. For 2 disks, okay, what should be my first good step? So this is my first good steps. See, the larger one should come from the beginning to the end one. See, now from the auxiliary one I can put it back here. So check. each and everything in at end. So from the beginning you are going to end and you are taking the help of auxiliary one. So with the help of this auxiliary tower, you are doing this job. Fine. Now think about for n equal to 3, what you should do. I have already shown you in a small diagram. Right now check. So first of all, this small one should come here. Okay. Now the middle one should go here. Okay. Now the smaller one should go here to give this one a space. So smaller one gone here, no issue. Now the bigger one or the larger one will get some space to come at end. So the larger one will come here. Fine. Now what is happening? So I am putting back the smaller one to the beginning one. Fine. So this is your step. Now the final step should be the middle one should come here. So middle one came here and the smaller one will go here. Check, the smaller one will go here. So right now you have, I think you have understood the steps. The steps are given. We have to generalize this thing. So how to generalize this thing? So there is a mechanism to generalize the whole thing. So this thing I will tell you right now. Step should be from beginning to auxiliary. How many disks should go? n-1. So this should be the step, or here this should be the step. My second step should be now one disk from beginning to end. Hello, tell me. So from beginning to end, I will move one disk. Okay. Now the third step should look like this. Now the n-1 disk in auxiliary. So I have to put this n-1 disk to the end one. So my third step should be all these n-1 disks from auxiliary should come to the end one. So from the auxiliary it should come to the end one. How many disks? n-1. So these three should be my step. Now the steps are not completed yet. Just try to think. From beginning you are moving n-1 disk to auxiliary. Can you move it directly? Can you move it directly? No. You have to take the help of the n tower. So here what help you need? N tower. N tower will help you. From beginning to end. From beginning to end. Who will help you? The auxiliary tower will help you. From auxiliary to end. So from auxiliary I am shifting it to end. Who is helping me? See, beginning is helping me. So here who will help you? Beginning will help you. So these are the steps and you are completed. Just try to see. Then I will show you the code. Just try to think about this. This is the main step. From beginning, I am trying to shift n-1 to auxiliary. So here n is 2, I have to shift 1 to auxiliary. Fine. Here I have 3 disks, so I have to shift 2 to auxiliary. Here we have done. Who will help me? End will help me. So end will help me. Second step should be from beginning to end. From beginning to end, I have to shift 1 disk. So see, from beginning to end, I have shifted one disk. So this is the step. So from beginning to end, I have shifted one disk. So this is the step. Who will help me? The auxiliary will help me. Now for the final disks, I have to shift n-1 disk from auxiliary to end. So from auxiliary to end, I will shift all the disks. How many disks? n-1 disk. Who will help me? Beginning. This tower will help me. So this should be your algorithm. So check what I should do. For n equal to 4, for n disk, what I have to do. So this thing I want to tell you. So all n-1 disk, where you have to move? You have to move auxiliary. See? Now what you have to do? What you have to do? One disk you have to shift from beginning to end. So you have shifted. Now what you have to do? From the auxiliary one, you have to put it at n1, n-1 disk. So 3 steps should be there. For the 4 disk, see, 3 disk, n-1 disk, that is 3 disk, I will move to auxiliary. Okay, so here this is your auxiliary. Now what I will do? One disk I will move from beginning to end. So I have moved one disk. The last step should be from the auxiliary, move each and every one to last disk. So this should be your step. So 3 steps. Again I am writing n-1 beginning to auxiliary. Who will help you? n1 will help you. Second step, one disk from beginning to end. Who will help you? Auxiliary. Third step, n-1 disk. So each and every one right now in auxiliary. So from auxiliary, shift it to end. Who will help you? The beginning one. So these 3 should be your steps. So check. For n equal to 1, move to the destination pole. For n-1 disk, to auxiliary pole using destination pole. We have told you, move one disk to the destination pole. Move n-1 disk from auxiliary pole to the destination pole. So these 3 your steps. So this is n-1 from beginning to auxiliary. Who will help you? n1. Now move one disk from where to where? Beginning to end. Who will help you? Auxiliary. And here n-1 disk from auxiliary to end. Who will help me? The beginning one or the source. Here beginning means source pole. So these 3 things we have already told you. So this should be your code. Check. If n equal to 1, so move one disk. So here nothing to do. So this is your base condition. Okay. So if n1 disk, so what you will do? From source to destination, nothing to do. For the 3 else cases, what you will do? n-1. So from source to auxiliary, destination will be your helping one. Okay. Next step should be for the 1. For this step, see, for this step, for one step beginning to end using auxiliary. your step, source to destination. Okay, and your third step, n-1 from auxiliary to destination. Who will help you? Source will help you. So how many recursion call I have to do? This is my first recursion call. This is my second recursion call. So this is recursion. This is recursion. So check these two steps are your recursion steps. So have you understood? This is your code. This is your code. Nothing to do. How to do the code? First one is number n. Second one is source. Third one is your destination. And fourth one is your helping one or auxiliary one. So n, the number is needed, right? For how many disks you want to do this? So the first one is your number n, for how many disks you will do. Second thing is your source. Third thing is your destination. And fourth thing is your helping hand. Now these three steps. So this is first step, second step, third step. First step, n-1 disk from peg, that is source peg, where you will move. Destination is your auxiliary, and who will help you? 2 peg. 2 means your destination. See, for the one disk, what you will do? From peg to peg, you will just move. That means from source to destination you are moving. Now again call this function. How many disks you will move? n-1. From where you will move? Auxiliary. So this is your source. Where you will move? To the n1. So this is your destination. Which will help you? The beginning one or the source one will help you, or the beginning one. This will help you. So what you have to do basically, you have to remember these three things. So I have written, last time I am writing this. So number, from, where, and help. Just remember these 4 things and you will understand. n-1 disk from where? From the source. Where you will send? Auxiliary. Auxiliary. Who will help you? n1 will help you. For one disk. From source, where you will send? n1. Who will help you? The auxiliary. For the last n-1, what you will do? From the auxiliary, where you will pass it? End. Who will help you? The source. So always remember these 3 rules. If you just write this, if you just run this code, it will show you from A to B, from A to C, from B to C for 2 disks. You can do it for 4 disks. So this will be your output. So this is the end. So